Binomial probability distributions are used when there are two outcomes, hence binomial. So in this example, if you are running a sandwich shop, you are trying to upsell cookies and chips with customer sandwiches. When asked, there's a 0.7% chance that the customer will say yes. There are 5 customers. So what is the probability that 2 or fewer people will say yes to the upsell? Now, there are 6 different outcomes of these 5 customers. There are 0 customers buy, 1, 2, 3, 4, or 5 customers would buy. We want to determine what is the probabilities of 0, 1, and 2, right? So 2 or less. So to do that, we need to use our formula for binomial probability distribution. So the probability, x equals x, equals n factorial divided by x factorial multiplied n minus x factorial times the x 1 minus p n minus x. So we're going to do it at the beginning for 0 outcomes. So let's start over here. Probability that x equals 0 is the n factorial would be the total amount of customers, so 5. Our x factorial would be the amount of customers if 0 customers were to purchase cookies and chips. Now our probability of x happening of a customer buying cookies or chips is 0.7, and in this case it would be to the power of 0, because that would be 0 customers are, multiplied by 1 minus 0.7 minus 0. So this is for 0. Now as we go through here, a couple notes. 0 factorial always equals 1. So this would be 5 factorial divided by 1 times 5 minus 0, so 5. So 1 times 5 factorial, so 5 factorial divided by 5 factorial would equal 1, multiplied by anything to the power of 0 is always equal to 1. So multiplied by 1 times 0.3 to the power of 5. So if we determine 0.3 to the power of 5, we get 1 times 1 times 0.00243. And that is the probability at 0. So 0.24% would be the probability that no customers purchase chips or cookies. So let's do the same thing for 1. Probability that x equals 1 and we have, again, our sample size 5 by 1 5 minus 1 factorial multiplied by the probability power of 1, sorry, probability being 0.7, multiplied 1 minus 0.7 to the power of 5 minus 1. Okay. So this would be 1 multiplied by 4. So this is 5 factorial divided by 4 factorial, which would actually, well, we'll get to that, would actually equal just 1 factorial. So what we can do when we divide factorial is 5 divided by 4. So we can remove 4 and bring this down to 1. So times 0.7 to the power of 1, which will be 0.7, multiplied by 0.3 to the power of 4, 5 minus 1. So 1 times 0.7 times 0.3 to the power of 4, 0.0081, or 1 times 0.7 times 0.081, and we get 0.00567. So there is a 0.567 chance that only one customer buys a cookie or chips. And we can do the same thing for 2. Five factorial divided by 2 factorial multiplied by 5 minus 2 times 0.7 squared times 1 minus 0.7 to the power of 5 minus 2. Okay, so now we can go ahead and set this up. And when we multiply our factorials, we need to calculate these individually. So 5 factorial, which we can calculate down. So factorial, of course, is 5 times 4 times 3 times 2. So we can set that up. Times 1. And here we'd have 2 times 1 and 3 times 2 times 1 to the power of 0.7 squared multiplied by 0.3 to the power of 3. So 5 times 4 times 3 times 2 times 1 is 120 divided by 3 times 2 times 1 multiplied by 2, because 2 times 1 is 2. Gets us 12 multiplied by 0.7 squared, 0.7 squared, times 0.3 to the 3 array, which would be 0.027 So 10 times 0.49 times 0.027 equals 0.1323. So the question asks, what is the probability that 2 or fewer people will say yes to the upsell And so what we've done is determine the three probabilities of those three outcomes. And we can add them up. So the probability that nobody would buy would be 0.00243. The probability that only one person would buy would be 0.00567. And the probability that two people would buy would be 0.1323. So when we add those together, we get 0.404 or 14.4%. And that is how we can use binomial probability distribution to determine, when there are two options available, the probability of an outcome occurring.